Mostly empty, which is why overpowered, but pretty nature.
That and the bottle opener on the back they have on them. All right, we're gonna get started. I know the lunch line's pretty long. People can just come in and interrupt. My name is Joel. I'm a principal DevOps engineer for a company called Research Innovations. Big long background in web development, switched over to operations side of the house. Been doing that for about a decade now. Print is really tiny. I'm a terrible learner through lectures. If you guys want to talk about SSO, IAM, AWS, DevOps, or even speaking at this conference, I'm very lucky. This is my third time doing a talk with this conference. Email me any word you can think of, 2023@joel.codes will come to my inbox. I have just a regular expression set up, so anything you want to send that way will work. Happy to converse with anybody. So we're going to start with what is SSO. I feel like most everybody in this audience is already going to know the answer to that, so we'll buzz through this quick, right? Single ID for all your applications and things of that nature. It's by nature authentication, but not authorization. So who you are, not what you're allowed to do. Besides a single ID, you also have a single source of credentials, right? So it's like the equivalent of a password manager. So in a large enterprise organization, you're not resetting passwords on 27 applications. If somebody forgets a password, you're resetting it in one spot. There's a couple protocols used to drive SSO, but the biggest is SAML. It consists of a client, an identity provider, and a service provider. The client is you yourself, the end user. The identity provider is the person who can prove or who you can verify you are who you say you are. The service provider is the application you're trying to use. So in terms of an environment, that service provider might be something like Jira, GitLab, AWS. Your identity provider might be backed by AD, Okta, a different identity provider of your choice. Essentially, the way it works is it's a pretty common scheme we see implemented in a lot of different ways now. But once you authenticate, the identity provider signs a token proving who you are. So the service provider can take that token, go back to the identity provider and go, did you sign this? Yes, I did. And it'll have a timestamp in it of when that token expires. Move on to the next slide here. So there's some benefits to using AWS SSO, very simple staffing changes. So you start getting into bigger companies where IT onboards, offboards, things like that. It's really annoying to have to deal with constant change in staffing. But additionally, some of those staffing changes are sensitive. And so having timing, when do you let a DevOps person know that somebody's being let go? How far in advance can you do that? And also emergency staffing changes. You can completely remove yourself out of that loop. The compliance requirements are amazing. Things like 2FA, password strength, all of that. They're no longer on you. They're on the identity provider. So as long as you're not using AWS as the IDP, that becomes somebody else's compliance problem, right? How many of you guys here do role assumption? So if you need to pop between accounts, you've got an assume and a role, and then you can get into that account. And in the web UI, it's in that stupid toolbar, and you've got to have a wiki page with what roles you're allowed to assume where. At the end of this thing, this legitimately takes 10 or 15 minutes to implement. That all goes away, role assumption, all of that. You don't have to distribute roles to all these separate accounts. You can do it all automatically through AWS SSO. It's so nice. The other benefit, of course, is no long-lived API credentials, right? No secret key, access key. They expire they last up to 12 hours and expire. So that's like another compliance benefit. So when you offboard somebody, it's not like where all of their credentials been baked in. Did they bake them into some third-party integration? Your developer just can't do that. You can still get those temporary credentials, but they expire. So it's kind of another way to enforce best practices inside of AWS. So the biggest question is, I keep talking about an identity provider, the person who decides who's who. AWS SSO can serve as your IDP or your identity provider. Anybody have any guesses why you don't want that? Well, one, you don't want to be in charge of that problem. Make it somebody else's. But two, as you start integrating other applications, the ease to integrate those applications it's far easier in other services, like Okta can help you integrate with hundreds of thousands of applications. But if for some reason you have an exec who comes in one day and says, we're shifting to Azure or GCP, like then you're going to have to like have people sign into AWS to get into Azure until you do the cutover. Also, if you have billing people or salespeople using like Sugar CRM, having them sign into AWS to get into Sugar CRM, like it's all a very weird flow. So it's a little bit more comfortable for most people to start with like Okta or another service like that. So this next slide plays into why you may not want to use something like Google can, if you pay for Google Apps, they can be an IDP, and Microsoft can as well. SCIM is a way to provision users. So I'm going to go over integrating with Okta. So what happens in Okta is you add a user in Okta and it'll just automatically show up in AWS. If you use Google as your IDP and you add a user, Google doesn't support SCIM. They think they know better. So what you end up having to do to use Google as an IDP is you have to have an event bridge function that runs every 5 minutes, which calls a Lambda, which calls into the Google API and dumps users and then go and stuffs them into AWS SSO. Believe it or not, Microsoft has it slightly better. They have an app engine and they run an application that implements SCIM. It's not baked in.
So it should just use like OpenID or SAML to do that.
So SAML doesn't do the provisioning. It does the authentication. So SCIM is the provisioning, right? So when you integrate with SAML, it doesn't always, it's a pain. Some applications, there's different ways to implement it, but primarily, SCIM is like, so it's an IETF task force, Internet Engineering Task Force, RFC, and there's just rough implementations of it. But I think Okta has like 70% of the market and they support it really well. So we're just gonna fly through getting set up with Okta as an IDP using AWS SSO. I have a bunch of screenshots, things like that. So we're gonna run through that really quick. It's as simple as enabling Identity Center in AWS. If you're not using AWS organizations, it will prompt you to enable that as well. So pretty straightforward, just some buttons you can click to do that. This is not readable in this format. It will be in the slide decks you guys can download. You get a lot of very useful information, both on the AWS side, and you get a fair amount on the Okta side as well. So in Okta, it's as simple as logging in, going, I have a new application that I want my users to be able to use when they sign into Okta. You pick AWS. There's values on the Okta side, you jam into AWS. Values on the AWS side, you jam into Okta. The one interesting thing we'll cover is there's a certificate that talks about like to secure and sign the tokens that are exchanged. The thing to know about that is it expires every year. So that's one thing you have to maintain, although interacting with SSO once a year is far better than hiring and firing going on weekly and daily in some organizations. So just start by adding that integration in Okta, and you can just label it however you want. In this case, I have it saying AWS IAM Identity Center. I work in an organization that has commercial AWS and GovCloud, so we label them like that for the users to find. And in this page, you can see where you can grab a token out of AWS, and you can grab this SCIM endpoint URL. I have a very, very important slide coming up that will talk more about that SCIM URL. Let's see if we can skip to that. So this is the one thing to take away from my talk. If you're integrating with Okta and AWS, they give you a URL with a trailing slash on it, and you will get back an AWS error, which, as we all know, means nothing, like it's just indecipherable. I think I spent 4 hours on this. You pull that trailing slash off and everything works easy peasy. This is the error you get. That's, doesn't match the pattern, but it doesn't tell you what the pattern is. So here you can see when you're assigning the Okta app, you want Okta to create users for you, update user attributes, and deactivate users. That's really critical. That's what it's using that SCIM for. So anytime you create a user in Okta, it'll create it over in AWS. Deactivated users is really cool. The users still exist in AWS, but when you go in and look at AWS SSO, they'll show as deactivated. There's a status column, and that helps in IT compliance because there's fears from IT departments like, is this user's access actually revoked? And it's more comfortable to see that the user's deactivated rather than just disappeared. I should back up, and something I should have started this whole talk with is I keep saying AWS SSO. I've been using AWS for a long time. It's IAM Identity Center. If you type SSO in the service bar, it still matches. That was its old name. And you might wonder why I'm showing you guys a lot of screenshots of GUIs. AWS IAM and Identity Center, or the artist formerly known as SSO, does not have strong APIs. So a lot of this configuration step is all click ops. It's terrible and it stinks. When they renamed it from SSO to Identity Center, they added more APIs, but none of it around the initial configuration and setting up. All the APIs were around some of the details we'll get into coming up. So this is configuring the CLI, which I think is pretty cool. So over here, there is a URL that you get when you look at AWS SSO. All of your users can sign into the web UI. They can get this URL. And then when you come over to the configure side, it's pretty straightforward. So just say in front of the microphone, you enter in your configuration URL, the region, and it actually will prompt you with the various accounts and roles you have access to. So it's very friendly for anybody to get up to speed developer-wise. So anytime they call AWS configure, it will on the fly display all the accounts. Additionally, like if you're an administrator on AWS, it's best practice to have read-only access. So you're not logging into other people's accounts with destructive permissions. So it'll show you the various IAM roles you have access to when you sign into those accounts. The old days, we'd all have a wiki page somewhere with like, run AWS configure, enter this value, go get your access key, go get your secret key, make sure you're rotating that every 90 days. We have a Lambda to enforce all of that just goes away. You can just always just call AWS configure SSO to get set up. And like I said, there's a 12-hour timeout. Credentials expire, and all you have to do at any time is type AWS SSO login. This little piece here that you see, a couple things to note. You've got to be running version 2 of the CLI to use AWS SSO. If you're like me, you still want to punch Bezos in the kidney because they have not and will not distribute the CLI using pip. And so it's a binary installer and copies files around, and it's like, are you freaking kidding me? So my initial reaction was to use a Docker container. When you use a Docker container for the CLI, it cannot launch a system browser for you, right? You're off in a walled garden. So if you're running it in a walled garden like that, you're going to have to copy this URL in, enter the code to finish the SAML lifecycle, which happens through a browser where it redirects off to the IDP, you verify who you are, and it comes back. If you're running it on the local system, not in a Docker container, your browser will open up, your default browser will open up, pop to a page. It'll automatically put the code in for you, automatically submit, and you'll have one button to click that says, yes, I'm cool, let's do this. This can be a painful flow if your organization doesn't require people to sign in once a day. But at a company like mine, where email and Slack and everything else is wrapped up behind Okta, and we require people to sign in every day, you sit down, you get through your Okta flow, you do your MFA, you check your email, And then when you go to work on AWS, you just type AWS SSO login, and it's fairly hands-off. You're not searching for your phone, your MFA app, you're not typing codes. It's really, really handy. So we talked about authentication. So authentication, as I said, is mostly handled by SSO. But it also helps out with authorization. And I believe that's one of the big reasons behind the name change between SSO and IAM Identity Center. So the big workhorse in SSO is permission sets. So permission set is just a way of grouping key components. You have users and groups. So groups also can be pushed out of your IDP. So if you've got AWS admins, junior admins, high trust developers, low trust developers, and groups, you can push all those groups automatically as well. A permission set also has accounts, AWS managed policies, customer managed policies, inline policies, and permission boundaries. Permission boundaries is kind of an advanced topic if you guys haven't played with that before, so we're going to skip that one for this. But one of the things I want to discuss when you're creating a permission set is users versus groups. Which one do you assign to? Well, groups, always groups. Don't ever assign anything to a user. Again, one of the big features of this is so that IT isn't bugging you. If IT knows what groups to put people in, you're good to go, right? You have your baseline permissions defined. So you as an AWS administrator are only handing out permissions to groups. If you assign it to a user and I get fired and my replacement comes back in, then you've got to get in and Terraform or CloudFormation and run all this stuff. Just skip it, just use groups. Accounts, use your best judgment. That's up to your company's decisions. You should be in an organization, you should have multi-account level access. I use, for example, like we have a billing group, they get access to our main account in the organization because that's where you have to go to see the billing. They have limited permission there. We don't give them wide access. It's very easy to just list out which accounts they have access to. Oh, this is a big one. Takeaway, skip the AWS managed policies. They're preset policies. They're ones that can't be edited. Don't bother. Your next choice, again, if you're just getting to learn this and you're clicking around in the UI, the next option you'll see is custom permission sets. That's where you want to be. I always go there. And you say, well, you said skip managed policies, and then you say AWS managed policies. Well, there's a difference between the two. There's managed policies in SSO, but the managed policies under the custom permission set is what you expect. Those are like the AWS default administrator access, AWS default read-only across every resource, things like that. The benefit of those is they exist in every account already, right? Every time you spin up an AWS account, there's an administrator access IAM policy. There's, read-only every service, read-only S3, things like that. There's customer managed policies and there's inline policies. So customer managed policy is a policy that you define. So we're back into that kind of IAM assume role nightmare where you have to have the policy existing in the account before you can use it in a permission set. So if you have a policy that says AWS Midwest Community Day demo policy, and you put it in a permission set and you spread it across your organization, if it's not in that account, you can't sign in. So you have to use Terraform or a tool like that to deploy that policy across everywhere. Inline policies, on the other hand, you can define in the root of the org. So you're saying, I have this permission set, I have group developers, and I have account development, and here's the policy that I want you to deploy for me. It has all the limitations of an inline policy, but you'll almost never have any issues using that. The big reason you might want to use a customer managed policy over an inline policy is if you're in a shop like mine, my philosophy is AWS as a service within the company. So I don't tell you how to run AWS. I set you up with an account. I give you admin access, and then I install all kinds of compliance stuff to keep you from hurting yourself, but you yourself are in charge of your account. So if you're on the Volvo car sales team, you're the admin, you own that account. And if you want other people to log into your account, you define that policy and let me know what the ARN is. And I can push out a permission set that says use that customer managed policy for that group of people. It's a really handy way to share that responsibility boundary. This is my personal AWS account. Try not to laugh. When you sign into the web UI using AWS SSO, you get presented with just a square box up top. You have to click it. It doesn't expand. It's annoying. If you're crazy enough to use AWS as an IDP, there'll be other boxes for other applications up there. That's why this doesn't expand. But as you can see here, they all start minimized and then you have to click again. And then you can see the name of the role you have. The pound changed as the account ID. The administrator access below it is the role. What's interesting is you can click management console will take you right into the web UI. You can get to work. There's none of the assume role. Remember the role name, find the account ID, all of that crud. And then if you need secret key, access key, that kind of thing, it's hidden away. You can just click command line or pragmatic access. It actually spits out like a full page guide. Here's how you set your environment variables and use these keys. And by the way, they only last for 12 hours. So it's kind of handy. So it looks complicated. It's really not. And that's why I was saying, like, legitimately just send me an email if you're taking this on and you just want to bounce ideas or talk or whatever. I'm happy to discuss with any of you. They very strictly say don't live demo anything. I wish they would have let me. It takes me under 10 minutes. The good news is if you guys have, if you're going to use Okta as an IDP, they do free trials. Sign up for one, throw an AWS account on a credit card, practice. It's very easy to get the two talking. Any questions? I went really fast. I'm just trying to cover as much as I could.
Kind of related, so like a lot of breaches recently, like LastPass and a couple of the major ones were like session hijacking, where like someone's cookies got stolen and they might use it to either go directly to the account or to the SSO. Do you know of any, like, if anything, because from what I understand, like basically once you're logged on, there's now anything recognizing IP addresses or recognizing like multiple logins or anything. Like so basically there's something to recognize using the same cookie twice. Do you know of any like mitigations for that? I should be technical with that.
So I'm not a security guy. I've had a few security good luck things on my resume, but if you're trying to protect your AWS account from outside access, honestly, the simplest way, and I hate myself for saying it out loud, is your IAM policies, or even at SCP level, just restrict access by IP range. And everybody goes, oh my gosh, how are we going to keep that list up to date? Well, it's straightforward. You require a VPN. So all your traffic to AWS comes through 1 or 2 or 4 endpoint IP addresses, and all other traffic simply gets denied. Because with IAM, a deny always applies before an allow.
Can you restrict it? Like I know with like Okta, you can restrict it to like specific company on device.